Good morning. Today what we're going to do is continue on with section 6.2. I got a few more things to talk about in terms of the characteristics of the equations of a polynomial function in Foundations 30. So just a quick recall of what we did yesterday in the beginning part of section 6.1. We were discussing the degree of a polynomial. We were talking about that highest power, whether it would be a power of 1, power of 2, or a power of 3 on a polynomial function. Recall what the shape of the graph is going to look like. Degree 1 are linear. Quadratic power of 2 are going to be those parabolas. And those cubic functions have that curvy shape there. And it's important, again, that we can be comfortable with the degree and the shape that goes along with them. When we were talking leading coefficient yesterday, we talked about how if we had a positive leading coefficient in front of that highest degree term, the positive would imply that we had something that was rising from left to right or concave up from left to right. So linear function going up, quadratic going up, cubic function going up when we had a positive leading coefficient, as compared to a negative leading coefficient if we had a downward trend, concave down, downward trend, that went with a negative leading coefficient. And that constant term, that plain old number at the end of your function, was always going to be your y-intercept. And so that was a kind of, that is a summary of what we looked at yesterday. The goal today is to now put this into practice. Can we see these characteristics when we're looking at different equations? Here's a matching question. There are 6 different polynomial functions given to us. There are 6 graphs. Can we match which graph goes with each equation without relying on technology? And justifying your reasoning is very important as you go through. So if you take a minute to look through the 6 equations, the 6 graphs, start to put together what you can see in terms of characteristics in the equation and how they match with the graph. Because my expectation is that you will be able to connect those pieces. So for example, I'm taking a look at h of x right here. I can see right away that it is a linear, it's a degree 1. I can see 2 possible graphs that it could go with. So I'm looking at some of the characteristics like the constant term, -3. That's the y-intercept. I see a y-intercept at -3 here as well as here. So far, could be either one. I see a negative leading coefficient, which means that the graph should have a downward trend, which they both do. So how do I distinguish which graph is going to be h of x? Well, that recalls remembering a little bit more about some of our characteristics, such as the fact that this a value is the slope. Which of these graphs have a -1/2 slope? So if you recall, going from point to point, that our rise is -2, our run is 1. Well, that doesn't match -1/2. It matches, whereas the other, way over here is the other linear equation. And so that is a better match for this. So I would say that this graph is going to be q of x, the one that says -2x minus 3. But I really want you to be able to put together the connections, such as the fact that you see this constant term. Where is it? There we go. We see the y-intercept. Not just that the y-intercept is -3, but it matches the -3 in the equation. That we see a leading coefficient that's negative, that matches the downward trend. It matches the slope that we see here. So that's the kind of thing that we're going to want to do. It gets a little bit messy. Maybe you don't want to connect the things, but you're going to have to say in words. So that means my h of x that I started looking at better matches this graph here. I'm going to write this down. H of x is -1/2 x minus 3. So that y-intercept that I see here, I see it in the equation, and I can see where it is in the graph. This negative leading coefficient, I can see in the shape of the graph, but I also can see that it's downward, and that I might want to identify the slope. Now, where can I find some good points? Here and here are some good points. So I can see that dropping 1, running 2. I can see the slope equaling -1/2, which is what I see here. So yes, it does get a little messy, but that's the kind of thing that we need to be able to do. So we've got Q of x and H of x taken care of. Let's go on to this graph. I see a parabola. That means that I'm talking about something that is degree 2. Now, I have a degree 2 here, J of x, and K of x. So what's the difference between our equations? Because I see a positive leading coefficient in both of them. That matches this. But I see a different constant term. I see -2 or +1, and that's going to help me with my y-intercept. So the fact that my y-intercept is at 1, I say K of x is a better match. So I can see x squared minus 2x plus 1. And again, I want to connect what I see in my graph to my equation. So my y-intercept is at 0 and 1, like the one that I see in the equation. What else do I see here? I see a positive leading coefficient, and I see a graph that is concave up. This is connecting the equation to what I see in the graph. And degree 2, I can connect it back to the power that you see here. So there's a few things that you should be able to do. That takes care of K of x. Well, where's my other parabola? Here it is. So that has to be J of x. But I still want to make sure that I am making the connections between the equation and what I see in the graph. The y-intercept down here at -2 goes with this -2, not this one. This is my y-intercept at 0 and -2. That's what I see in the graph, and that's connecting to this part of the equation. And it's going to seem a little bit familiar to the last one. It's a little repetitive. I see a positive leading coefficient, and it goes with the fact that this graph is concave up. And so those are the things I see. Degree 2 equation, and that matches the shape of the graph again that I see there. So there's things kind of all over the place that's messy, like I said. We have 2 cubic functions that are left. We've done 4 of our equations. So when we talk about the difference between these two, what I look at is I see this graph is rising from left to right. I see an increasing trend. So I'm going to be looking for something that has a positive leading coefficient. And it looks like P of x is the one that has the positive leading coefficient. I'm going to write it down, and then we'll talk about how it fits with the graph and the equation. All right, so positive leading coefficient, I can see that positive leading coefficient here, and I can see an upward trend in my graph. Upward is what I see in the graph. The positive leading coefficient is what I see in the equation. The fact that it is degree 3, and that matches with the shape of the graph that I see. And what else? I have a y-intercept down here at -2 that matches this -2. So I can put those together, and I can say that my y-intercept at -2, at 0, -2, matches my constant term. Well, that only leaves us with one equation to go, and of course it still has to make sense. I have g of x is the only one that I have left. I'm going to write it down, and then we can discuss how it is a good match. -x cubed plus 4x squared minus 2x minus 2. So what do I see? I see a negative leading coefficient, and I see a downward trend graph. That is a good characteristic. I see degree 3. And the shape that I have matches in my graph with degree 3. And don't forget my y-intercept at -2 to that -2, that I have a y-intercept at 0 and -2. So it's really important that you have at least a couple of reasons why a graph and an equation are a good match. All right, that's part of what you're going to need to be able to do today, is to take a look at an equation and pull out those important characteristics and see how it fits with a graph. Well, the next equation is a little bit of a switch on that. This time around, they're not giving us a graph or an equation. They're just giving us, some characteristics. And they're asking us to sketch the graph of a possible polynomial function for each set of characteristics. So they're telling me about the range of some polynomial function and its y-intercept. Now, based on the range here, what I'm seeing here, it has to be a quadratic function. Quadratic functions are the only type that have a limited range. Linear and cubic functions have a range that's like this second example. So I know it's quadratic. I also know that because it says y is greater than, this part of it is telling me that it's going to be concave up. Y-intercept at 4, meaning that it's going to have the graph go through 4. I really don't know much more than that. I know it doesn't go any lower than -2. So maybe my graph is going to go down, something like this, come up. It's not a very nicely shaped parabola, but the general idea is I've met the conditions that were laid out for me. Okay, so I have a possible graph sketched based on the characteristics. Let's take a look at B. The fact that the range is all real numbers means that it could be linear or cubic. Both of those types of polynomials have a range that is all real numbers. But the turning point piece of information now says there's one in quadrant 3 and another in quadrant 1. So what we have here are 2 turning points. That is only possible in a cubic function. All right, well, I know I've narrowed it down to a cubic function. So a graph. It had a turning point in quadrant 3. Quadrant 1, 2, here's quadrant 3. I'm just going to put a point there, down here in quadrant 3, because I know it's going to turn here. And another in quadrant 1. It's going to turn there. Doesn't mean it starts there. It means that I must be turning there. So I'm going to have to decide, is it starting increasing and turning? Well, if it turns that way, I'm never going to hit this one up here. What if I start up here? If I draw it down here and it turns here, yes, I can then hit this one and turn again and come down. So I'm guessing that I have something that's going to go down, turn. I'm not too sure where it's going to go. It's going to hit there and turn though, and come back down. So I have myself a cubic function that meets the conditions that are indicated in part B. Now, I haven't drawn great graphs and I don't know a lot more about the equations, but that's what this last part is. It says write a possible equation for each function above. Use technology to check and adjust your equation so that it satisfies the given characteristics. So in terms of making an equation for this first graph, for part A, this is what I know for sure. It is concave up. I'm going to have a positive number in front of my x squared. I know that it is going to have a constant term of +4. These things I know for certain. I have to have the positive, the x squared, and the 4. Everything else in between, the middle term that goes with the x, I'm not too sure what that is going to be. I'm not too sure what the actual positive number is going to be. This is where you can take out your calculator, play around with plugging in, trying different numbers to see if you can adjust the equation so that it does, have this range where it is going to go down to -2 and not much more. So it's going to be hard to be perfect, but you can get something that's relatively close that would fill in the missing pieces around the important required characteristics or values, I should say, in the equation. So what about part B? What do I know about this graph and its equation? Well, it has a downward trend, first of all, so I'm going to need to have some negative number in front of an x cubed. It's cubic, I need a power of 3. I really don't know much else about the rest of my equation. I'm going to have to play around with some numbers for the x squared, the x, the plain old number term, in order to make it have that turning point down here in quadrant 3 and a turning point in quadrant 1. But these two pieces, the negative and the x cubed, are necessities to make it have a beginning of what I see happening in my graph. But again, you play around to see what kind of number that you want to have as a negative number. What kind of terms do you want to have that come after the x cubed to finish the equation so that it will look something like our sketch? And that's the kind of thing that we're going to do to finish off section 6.2 is a little bit more work with the equations and trying to make them do what we want in terms of a graph. That's all for this last part of section 6.2. Have a good day.